Hopefully this will go well, but I'm thinking maybe you need a reminder. I don't know. I don't want to insult your intelligence, but I want to also make sure I do a good job. So, there are 4 types of graphs you need to be able to do at the end of this lesson. Graph sine and cosine with even the ugliest factors. Can you do that? We'll see. Can you graph secant and cosecant? We'll see. Can you graph tangent and cotangent? We'll see. And can you graph reciprocal functions? You might even say, what does that mean? Okay, well then, here we go. The idea, first that I'm starting off with, is reciprocal functions. Given an original function, you should be able to tell me what the graph of its reciprocal looks like. They'll have relationships, but obviously they're not going to look the same. So let's start with what those relationships are. Let's actually do this all together. Let's start here. What does that graph look like? And then I'll come back to these notes. Graph f of x on the left real quick on your own. You should be able to do that. Graph that, and then we'll proceed from there. You could go by ones or twos, whichever, or halves, whichever you prefer. If you wanted to spread it out, I don't care. Okay, I'm seeing most people about done. What's the overall shape of this? If you distributed it out, what would the dominant term be? X cubed, positive or negative? Negative x cubed, okay? Negative x cubed could look like this, or it could take as much as 2 turns. But it goes to the positive direction at the negative x's and the negative direction in the positive x's. All right. Factored form makes it easy to place roots. Roots are 2 there. Is the root here 3 or negative 3? Do I just take the opposite of what's here, or do I have to think what would make this 0? Think what would make it 0, and that is 3, not negative 3. Okay, so 2 and 3 are the roots. Are we cool there?
Yes.
All righty then. In terms of sign analysis, I know it's going to do this and this. What about in between 2 and 3? What happens? Pass through, bounce off, what? Bounce off which one? 2. Why does it do that? Because it's squared, there will be no sign change there. And so it was positive before and positive after. 3 minus x is to the first power. That's an odd power. There will be a sign change there, so it will pass through. What's the y-intercept? Just for fun. What? 12. Yeah, if x is 0, y would be negative 2 squared, or 4 times 3 is 12. Okay, so the y-intercept is up here. Please check your shape. It's very steep, and any calculus student with the salt knows that. It's not lightning bolt, okay? It doesn't grow like that. It grows steep. Cubes grow fast, right? All right, now, the topic of the day then is, what about if you graph the reciprocal? Let's start here. Where the graph of f has zeros, 1 over f will have 1 over zeros, or what does that mean graphically? Undefined, which means vertical asymptote. So I'm going to have vertical asymptotes at 2 and 3. Really thin region there, all right? Next, where the graph of f is positive, well, 1 over f will also be positive, because taking a reciprocal doesn't change that. It doesn't make it negative all of a sudden. So positive will be still positive, and negative will still be negative. So I know that the graph will be up here, and down there. It won't obviously look like circles, but that, I know it'll be above and below the axis in the exact same way that this guy was above and below the axis, because taking the reciprocal doesn't change the sign, right? Last but not least, two ideas, reciprocal ideas. The reciprocal now. Where the graph of f is large, which is to say big Y's, or far from the axis, so the reciprocal will be 1 over y, which is small. And therefore, small y's. Okay? So let's go, erase these now. Okay? Let's go way out here. This is a really big y. Well, over here, that'll be 1 over a really big y, and so a really small. What will it look like? Small y's are in here, yeah? So it'll be close to the axis there, but above. And over here, these are big negative y's, and so over here, they'll be small negative y's. Cool? Last but not least, the other idea, where the graph of f is small, which is to say small y's are close to the axis, f is, or 1 over f is large, far from the axis. So as this gets small, 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 this y, for example, is 1/10, maybe, somewhere. The reciprocal then would be 10. So as we get smaller and smaller here, the reciprocal will get larger and larger. And right here, as this gets small, small, small negatives, the reciprocal will get large, large, large negatives. And then the only thing left is this region here. I didn't really graph the maximum with any effort. I have it topping out about 3/2. I don't know if that's right or not. But how low, say that was right. Say this is 3/2. Then what's the point in here that's going to be the reciprocal? 2/3. It'll be 2/3. But then it's, as this gets small, this guy gets large. And as this gets small, this guy gets large, and so it's actually going to be a really, really thin parabola here. But it has to stay positive because reciprocals are positive or positive. You follow? That's a reciprocal graphing idea. Have you done that before?
No.
Alrighty then. That'll take practice. We'll practice that in a minute. Learn. Okay, let's go on to the next idea, which is sinusoid graphing. Here we go. This I touched on a little bit. I just want to review. So when I go to graph this sinusoid here, I might start by saying I know it's a negative sine wave. It looks like that. Then I might find the period. What's the period? It's always 2 pi divided by the coefficient of the x. So 2 pi over 4/3 is is 3 pi over 2. Okay. I then know that a full wave is 3 pi over 2. Now I want you to find accuracy at not just the wave in the beginning, but half and quarter points. What's half of a wave then? Half of 3 pi over 2 is 3 pi over 4. Half of that then is 3 pi over 8. Every quarter wave is 3 pi over 8. 3 pi over 8, 6 pi over 8, which reduces to that. 9 pi over 8, 12 pi over 8, which reduces to that. Okay, every quarter wave is 3 pi over 8. Are we cool? Yes, we're cool. Okay. Let's go. Yeah, that's all right. Do what it is. All right. Now then, what does this guy do? That 3 pi over 2, what does that do to the wave? Shifts it over. Well, luckily here, 3 pi over 2 is actually a full wave. So it's going to shift over just one whole wave. And so I can really just graph a normal wave. Last but not least, the vertical part. What's the center line at? 0. What's the amplitude? 1. Let's space this out a little. I'm going to make this a little bigger and go 4 boxes to 1 and to -1, just so it's not sitting right on the axis and it looks a little better, right? Now, then, last but not least, choosing a scale. I want to be able to find every quarter wave, so I need to be able to find pi/8. What's a good scale to choose? Pi/8. Yeah, use a pi/8 scale. That'll allow you to find 3 pi/8 and every other. Every other. So, now we said that this shift was pretty much a non-factor because it shifted over one complete wavelength. So my first point will be just like I see it at the center line and passing through the origin. My next point is going to be a minimum at 3 pi/8. So I'll go over 1, 2, 3 boxes and put a minimum. Yeah? Then the next point is the center line. So 1, 2, 3 boxes, center line. 1, 2, 3 boxes, max. And so something like that, right? Sort of. What's wrong with that? Okay, this actually is a problem on people's homework that you will be losing points on the way I grade on a test, okay? The way I grade on a test is -1 for every quarter wave point not shown on the space provided. So this person would lose 1, 2, 3, 4. Okay? A graph, I remind you, is a picture of points that satisfy the equation. And you're not only graphing points that satisfy, but you're also telling me points that don't satisfy. If you don't graph over here, you're telling me that there are no points over here that satisfy that equation. And that's not true. There are points. And so you will graph over the entire space provided until you reach the edge. Understood? Okay. By not graphing anywhere, you're saying there are no points there, and that is not accurate in this case. All right. Would you try that guy on your own? The second one. Anybody at your scale yet? Horizontal scale? What's your horizontal scale? Going by? I would go by 1s myself. Call. I guess you could also go by 2s. It wouldn't be terrible, but I'd like 1 better. Am I getting pretty wave? I can do a full wave if I go by 1. Right? Or not yet. Your silence indicates that you're not ready. Okay? All right, do you agree that the center line is 2? Do you agree that the amplitude is 4? Okay, do you agree the positive cosine wave is peak to peak? Okay, do you agree that the period is 24? Yes? Okay, it's 2 pi divided by pi over 12, that's 24. So that means a half wave is 12 and a quarter wave is 6. So I need to choose a scale that we locate 6s or multiples of 6s. Also, though, I would like to choose a scale that helps me locate the shift of 1. Is that left 1 or right 1? Left 1. All right, so did you choose a scale of, I can imagine you either going by 1 or 2. 6 to me would be pushing up too tight. What did you go by? 2s? Okay, 2 sounds not too bad. All right. So if I go by 2s, then that first point, which is a peak, instead of being at the axis, is actually left 1, yeah? Now each quarter wave, so that based on my scale then would be between 2 boxes. Each quarter wave is 6 units away. Now based on my scale of 2 then, how many boxes am I going to go to get to my next point? 6 would be 2, 4, 6, basically 3 jumps, so you should have a space there, which is, imagine, at 5, then 2, 2, 4, 6, 2, 4, 6, and something like that. Then 2, 4, 6, middle, 2, 2, 4, 6, min, 2, 4, 6, middle. Depending on what your scale choice was, you might have a wave just like that, or it might be a little tighter or looser again, depending on if you went by 2s or 1s. Okay? Okay, good deal. Let's get a little harder now. Secant and cosecant. Recall the unit circle and the base graphs here. So, first, for sine goes 0, 1/2, root 2 over 2, root 3 over 2, and 1 there, yeah? Do you agree? All right. And this way you could say it's negative 1/2, negative root 2 over 2, negative root 3 over 2, negative 1 there. Now let's talk the reciprocals here. Cosecant would be the reciprocals. Well, let's start here. The reciprocal of negative 1 is negative 1. This is negative 2 over root 3, which we could rationalize. This is negative 2 over root 2, negative 2, and 0. Dividing by 0 is undefined, okay? And then 2, root 2 over 2, 2 over root 2, 2 over root 3, and 1. Now then, you're going to have, for cosecant, think reciprocal. I don't even know if that unit circle is worth it. Sine looks like this, yeah? And it has zeros at pi and 2 pi and 0. And so if I do a reciprocal graph, like we were doing before, One of the ideas is that where this is 0, the reciprocal will have a vertical asymptote. And that would mean we're going to have vertical asymptotes in a lot of places because sine hits the axis in so many places, right? We also know that in reciprocal graphing, the reciprocal of positive is positive. So I'm going to be up here and then down there when I graph the cosecant. The reciprocal doesn't change the sign. Last but not least, big versus small. Where sine is small, or approaching the axis, cosecant is big. So they're going to always touch, and you'll have vertical asymptotes and all these little cup-looking shapes between the two asymptotes alternating up and down. All right. So then, if I want to graph a cosecant, you might start by graphing or sketching sine, and then using that as a guide. Now that's just sketching. So 3 sine of x minus pi over 4. I know the amplitude is 3. Like that. That's the period for the sine wave. Any change or normal 2 pi? Normal 2 pi, which means a half wave is pi and a quarter wave is pi over 2, right? But we're going to shift this pi over 4 to the right, so what kind of scale should we choose? Pi over 4. Do you want to go pi over 4 to 1 box or pi over 4 to every 2 box? 2. Okay, let's do that. Pi over 4. Cool. Now sketching the sinusoid, that center line that was going to be at 0 is now going to be shifted right pi over 4. So that center line point will be right there, yeah? Now that next point, or each quarter wave, is pi over 2 away. Now if I did pi over 4, pi over 2 shifted right pi over 4, doesn't that put me at 3 pi over 4? How many boxes away do I go to the next point? 2 boxes or 4 boxes? 4. Based on my scale, if every 2 boxes is pi over 4, then every pi over 2 would be 4 boxes away. So 1, 2, 3, 4, max. 1, 2, 3, 4, middle. I'm kind of off the graph, so let's go back. Going back. 1, 2, 3, 4, min. 1, 2, 3, 1, 2, 3, 4, middle. 1, 2, 3, 4, max. Okay? Now, with those dots there, that'll probably be enough to start getting my cosecant graph. Where the sine graph is at the axis, or the center line, I'll have vertical asymptotes. So you should have vertical asymptotes everywhere your sinusoid is at the middle of the wave. Then, as far as above and below, every peak will be the low point of a cosecant curve. So my positive cosecant curve might look like that. On the left side, I'll actually have a downward opening cosecant curve at the mins. And this guy graphing over the entire space provided. I do have part of a cup over there. Make sure you graph it. Don't say, oh, I don't get a full one, so I'm not going to even bother. Yeah, you will bother. Even if it's a part one, put it down. You with me? Try one on your own. I recommend you at least lightly sketch the reciprocal, which in this case is cosine. Ready? Or nope. Okay. Right. Okay. So let me catch up to you. Did you go every box is pi over 4, every 2 boxes? Every box? 2 boxes? 2 boxes? You can go either way, I don't care. But. Okay, so then right pi over 2 would be, and then every pi over 4. Okay, so yes.
Why did you go down 2 for the knee?
Because I'm silly. I'll fix that, don't you worry. All right, there. Boom. A little more. How's that? Oh, thanks. Bet you wish you could do that. All right. Do you have, good easy check is, do you have a cup centered at the axis? Okay, that's a good first point. Also, do you have a point that could easily be located as pi over 2, negative 2? If so, then you're probably on the right track. That would mean your first cup is in the right place and they're spaced correctly. So, all right. Last but not least, tangent and cotangent. Let's go with, I'm going to ignore the unit circle, and let's go with the idea that tangent is sine over cosine, right? So you'll have vertical asymptotes where cosine is 0, and that is at, is this not what you're looking at? Am I in the wrong place? Why is there so much? We're good? Okay. Do you agree then that if tangent is sine over cosine, then you'll have vertical asymptotes where cosine is 0, which is at pi over 2, 3 pi over 2, 5 pi over 2, and so on. So the base graph of a tangent wave is pi over 2 to negative pi over 2, or a normal period is pi for a tangent curve, not 2 pi. Normal period for a tangent curve is pi. You go through a full motion in pi radians instead of 2 pi. Second, when I grade these, I expect 3 points per curve. Besides the vertical asymptotes, I need to see this point which shows, did you know if it was vertically shifted or not? I also need to show you to show these points because that's what tells me, do you understand the stretch or not? If those are located properly, then I know, oh, you knew this was stretched by a factor of 2 or it was squished by a factor of 2. Without showing those accurately, you are not communicating to me that you know that, all right? So if I do a tangent curve, it'll look like that. Cotangent is cosine over sine. And therefore, you'll have vertical asymptotes if sine is 0, which is at 0 and pi and 2 pi, and so on, unless it's been squished. So cosine actually has cotangent rather, has asymptotes at 0 and pi, and 2 pi, and so on. This would be 0 if cosine is 0, which is at pi over 2, but pi over 4 is still there. Now these waves go the opposite way because cotangent of pi over 4 is still 1 and so on, all right? Different asymptotes and reflected shape. Cool? Period's pi. Now then, say we do a tangent curve that's got changes. Q-tangent of 4x. Let's start with the period. The period is now, instead of pi, it's pi divided by 4, or pi over 4. Never mind. Why would I reduce pi over 4? That's what it is. Okay? Now then, what about the ends of it? Instead of pi over 2, they'll be 4 times as quick. So where will the asymptotes be? Well, it won't be a pi over 2, they'll be a pi over... pi over 8. Pi over 2 divided by 4 means it'll end at pi over 8 and end on the other side at negative pi over 8. That is a length of pi over 4 wide. Pi over 8, and that's negative pi over 8 is pi over 4 wide. The period has been squished by a factor of 4. This is a horizontal squish. So let's say we decide how many boxes we want to use. You want to go every 2 boxes pi over 8 or every 4 boxes? Let's go 4 because that'll be less work, shall we? I'm going to have an asymptote at pi over 8 and an asymptote at negative pi over 8. And it looks like I'm going to get another asymptote every 8 boxes. So my next asymptote would be just off the graph over here and just off the graph over there. You follow? Now, that center line point, normally the wave goes right through there, and that 2 doesn't change the fact that 0 is still 0. So that point through the origin will not be affected. But at the quarter wave mark, pi over 16, instead of going up 1, we'll go up 2. So you're getting a vertical stretch here of 2. All right, so then looking at the pattern of the waves, really there's still 5 important points. There's asymptote, min, middle, max, asymptote. So if I go on this side of the asymptote, the first point I'll get to is a min, a middle, or a max. Same way. A min. So that point there of 2 boxes in, 2 boxes down, then a middle, 2 boxes more, then a high point, 2 boxes more. Going the other way, on the left-hand side, I'll go 2 boxes and I'll be at a what? A max, a middle, or a mid. A max. And that max is really just a terrible choice of words. It's not a max at all, obviously, but you know what I mean. Maybe. All right. And so that's the way. All right. As much as I like to do this one, we're running out of time. Questions on sets? 29. Number 1. You have found the even answers, I hope, on the website, yeah? They're on my... Number 1. 29-1. Did I hear that? Yes? You do? Oh, okay. Sing well. All right, number one, anything else? Yes, 10. 1, 10, 14. 1, 10, 14. Okay, just a second, everybody. Now I lost track. 1, 10, 14, is that right?
Okay, like 3 times. One of those like counts. I don't know how, but I am.
So does that count?
Yeah. So when you like add them and divide by 5.
Hope you left too.
Yeah, I
You're
know.
going to be all awkward.
Yeah, this
You don't want to.
sounds to be like this small.
1, 10, 14. 1, 10, 14.
Oh, some people have crazy. Like weird, like.
Sorry.
What?
Oh, you guys want to go?
If you want me to.
If they don't get a microphone, then you surely may.
Good morning, Devlin students, faculty, and staff. At this time, if you have not done so already, please dismiss members of the Devlin Concert Choir to the landing outside of the library. Today marks the 17th anniversary of the tragic terrorist attack of September 11, 2001, the deadliest terrorist attack in American history. Over 3,000 American lives were lost in New York and Pennsylvania and Washington, D.C., including hundreds of police officers, firefighters, first responders. Over 10,000 more people were injured. On September 11, 2001, President George W. Bush said, "Terrorist attacks shake the foundations of our biggest buildings, but they cannot touch the foundation of America. These acts shattered steel, but they cannot dent the steel of the American resolve." Please join us today in honoring and remembering the victims and heroes of the attacks of September 11th. At this time, we ask that students, faculty, and staff open classroom doors and enter the hallways to listen to the performances by the Devlin Concert Choir under the direction of Mr. White, as they will be singing the Star Spangled Banner and God Bless America. Thank you.
rise to the Pledge of Allegiance. Ready, begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Colorado State University will be visiting today in the auditorium during 7 hours. All students are invited to learn what CSU offers you. CSU is home of Kim Graham, the brand new stadium on campus, and 4 Devlin staff members are proud of.
What university had a goat, donkey, dog, and now a bison for a mascot, but 12 Nobel arrests and 20 astronauts rivals for the Rocky Mountain Showdown? Steve Boulder is hoping to meet all of you on Wednesday, September 12th during 7th hour. Use the 7th hour after counseling and sign up on Naviance.
Bus taxis are available in the financial office for pickup. Stop by and get yours.
They're planning now for the Jeffco Grading Challenge. There are cash prizes available. Stop by the main office for a flyer.
Senior activities. All seniors who participated in the 80 Spirit Day today come to the senior lounge. 7 hours per picture.
The 28th and 19th mock trial season are coming through the Grading Center. If you're interested in joining us, please attend an informational meeting on Monday, September 24th at 6 p.m. in Mr. Carson's room. Second floor west. This is a short one, no dinner will be served.
Seniors, we still have more space for baby pictures. Make sure you submit for your favorite picture by the yearbook. You can pay for up to 3 pictures of your favorite child today. You only have 2 more weeks to be involved in the yearbook. That's my announcement. Have a great day.
Okay. So it sounds like for some these applications are an issue. I apologize. 10 and 14. Tangent of 2A. Negative 1/4. Okay. If tangent of A is negative 1/4, what's tangent of 2A? That takes a little bit of work here. Would you agree that tangent of 2A is sine A 2A over cosine of 2A? Let's start there. Or cosine of 2A. That's the same as 2 sine A cosine of A. These are identities we're going to have to eventually memorize. I'll let you know ahead of time. Dang it. All right, this time I really will put 1, 10, and 14 up at lunch. I was there at 7th hour, but I will put 1, 10, and 14 up. Or you can sign up in 7th hour. Make sure I get 29 today. Have a good day. Yeah, we're having a fun day today. I'm also here after school. Ooh, that's some good music. Who's playing the music? All right. Required